Hello everyone! Today's objective is that after watching this video you should be able to solve a quadratic equation of any form with the completing the square method. Now, I did a previous video on the completing the square method where there were some basic forms of equations that were very easy to use the completing the square method for, given, I think the first example was x squared plus 8x minus 13 equals 0. Now, the things that make this easy are there's no number in front of the x squared. Also, this number is even, right? And part of this method is you divide the b by 2, so if that's odd, it becomes easier, right? Now, if you haven't seen this yet, go watch the first video first. But now, we're not going to deal with these silly easy ones. We're going to get a little bit harder. Now, don't worry. If these weren't easy for you, it's okay. You're still learning. Practice it. I promise you, if you practice enough, eventually it'll get easy. That's the way anything is. All right, let's say we got a harder one. All right, let's say we got something like, I don't know, 3x squared plus 7x minus 14 equals 0. Okay. Now, maybe you could factor this with the with the AC factoring method. I don't really know. We could find out, but I'm just going to go ahead off the bat, try the completing the square method, right? Now, the first thing we got to realize is you got to divide this number that's in front, okay? So I'm going to divide everything by 3. Yikes. So I told you it was going to get hard real quick, right? Because look at this. None of these numbers are divisible by 3. Now, you might be wondering, wait, why do I divide everything by 3? Don't you just divide it by both sides? Well, yes, but remember, again, think about when you add fractions. If I have 1/4 plus 2/4, that's equal to 1 plus 2 to the 4th, right? So if you divide a whole bunch of things being added by this, it also works the other way. It applies to each term. Okay, so when I do it to this term, it cancels. Yay! Here, 7/3 doesn't reduce. Okay, so I got x squared plus 7/3 x minus 14/3 equals 0. Okay, listen, we're starting off hard. Now, remember the general form for a completing the square problem is basically use the general form for a perfect square polynomial, which is basically x squared plus bx plus b over 2 squared. You know that's going to become x plus b over 2 squared. Okay. Now, first thing you might remember that we add this part to the other side. So I've got x squared plus 7/3 x equals. Now I could get a decimal, but it's going to be a repeating decimal, so I'm just like, I'll just leave it like a fraction for now. Okay. So in this case, can you identify the b? Okay, hopefully identify b is 7/3. So b over 2, let's see, 7/3 over 2, that's hard. We'll invert and multiply. 2 is really 2 over 1. It's 7/3 times a half is 7/6. Okay, now notice this one is harder. It's really, most of this isn't harder, let's say, algebra things. It's just fractions. It's kind of a review of middle school math. I get it. Fractions are still hard. But if I divided that by 2, I get 7/6. Again, if you want to, you could do all these in the calculator. You get long decimals. I'm going to show this with a fraction. Okay? X squared plus 7/6. Wait, I'm not there yet. Sorry. Hold up. I got to figure out what b over 2 squared is. Okay, so if I square this, 7/6 squared. Remember, if you square a fraction, you square the top and the bottom. So again, let me remind you, this thing is b over 2. That's going to be important because that's going to be inside of the thing that is squared. You'll see what I mean later. So 49/36. That's what I want on both sides. Okay? So I'm going to add, sorry, let's slow down a little bit because it is getting harder with all the fractions, right? I know, sometimes I go too fast because I'm excited. But there's actually a setting in YouTube you can play it at like half speed, I think. So if you want me to slow down, you can do that. So plus see, I was distracted. Plus 49/36 to both sides. Okay. So what does that look like? Okay. It looks like x squared plus 7/3 x plus 49/36 equals 14/3 plus 49/36. Okay. All right. Now, the good news is, because I got this term over here on this side, the left side, I'm going to worry about the right side later because I'm just super excited. This now is a perfect square polynomial. So what's true about a perfect square polynomial? That equation, right? Over here. Where is it? There it is. This equation is true. So it's x plus, this is going to become x plus 7 over 6 all squared. Okay, that looks a little nicer. Now, let's figure out what this thing is. Okay, now, if you remember, how do you add fractions? Okay, you got to get a common denominator. Okay, so is there any, I just like to start with a small one. Is there anything I can multiply 3 by and get the other number? Well, it turns out, yes, if you take 36 divided by 3, you get 12. So that would mean that if I take this and times 12 to the top and the bottom, I get an equivalent fraction. Okay? So, if you take the time to do out, let's see, what is 12 times 14? Pretty sure it's 168. Let's go with that. 168 over 36 plus 49 over 36. Okay? Now, I like showing the fractions because, again, I just like fractions. You could use calculators and decimals, but I'm going to show it the fraction way so you know how to do the fraction way. Okay? Because it's so much more precise. You're not going to have any rounding errors due to the infinite decimals. Sweet. All right. So I add these together. I've got 217 over 36. Okay? Now I'm going to square root both sides. Take square root of both sides. So, again, same general process, right? It's just these are next level. You just got fractions to deal with. But I want you to see, compare this one to my level 1 video problem. Same process. Once you're at the perfect square form, you take a square root of both sides. And when you take a square root, it splits really into two equations. X plus 7 over 6 equals, I'll just leave it in this form for now. It's the positive version of square root of 217 over 36. And it's the negative version, okay? Again, watch the other video, I break that down. So the way you solve that, you solve it the same in both. Minus 7 over 6, minus 7 over 6. Okay, now at this point, if your final answer permits you to plug things into the calculator, right, you could type in square root 217 over 36. Again, some calculators, you might need to close a parenthesis there, then subtract a 7 over 6. And again, I'm just going to switch it around because it bothers me. I don't know why. Because I'm too much math nerdy. Kind of standard form is put them, even though it's subtracting, put the minus 7 over 6 in front. And also the reason that'll help, if you plug it into the calculator, if you put it in like this, okay, x equals negative 7 divided by 6 plus root, probably still need a parenthesis, 217 over 36. But it just makes it so, I don't know, it works. You don't have anything afterwards. Boom. Or x equals negative 7 over 6 minus 217 over 36. Okay? So, if we do those, let's do the decimal approximations first. So if I plug this in as shown, okay, I'm going to get 1.29. I see that 0.288, but it would round to 1.29, and I would get x equals negative 3.62. Okay, cool. So, you want the decimal approximation answer. That's it. You're good. Okay, now, if you want the exact form, one thing to note, yes, this is an exact form solution. That's an exact form solution. With radicals, though, there's this other thing about a fully simplified exact form solution. Now, notice, I'm just going to go over this. What is the square root of 36? Or first of all, there's a rule, right? If I have the square root of x over y, it's the square root of x over the square root of y. So you can take the square root of both, right? I happen to know that the square root of 36 is 6. So the first way I would do that is I would call this, and again, remember, if we wanted to, we could just pull this together. If I wanted like a fully simplified answer, because of my cool math notation, I could call it plus or minus root 217 over 36, which I'm writing it over here as x equals negative 7/6 plus or minus root 217 over 6, right? Because the square root of 36 is 6. So if you wanted to, you could even write it as a big mega fraction, plus or minus root 217 over 6, like a big, nice fraction there. Cool. Now, there is another step that if you want a fully simplified answer, sometimes these radicals can reduce even further if you can factor out a perfect square. If you know how to do that, that's great. In this case, this does in fact happen to be perfectly simplified. 217 doesn't have any perfect square factors. So this in the red would be your fully simplified exact form, where these are your decimal answers. All right, feeling good? Again, I know it's a lot of fractions, but to summarize, same basic steps, right? That you can do really for any, there's no problem, there's no quadratic that you can't solve with this method, right? The thing about factoring is only some quadratics you can factor. There's no limit to what you can solve with completing the square. It doesn't matter what these numbers are right here. Okay. Now sometimes there's cases where there's no solutions. I might cover that in another video. But whatever number's in front, you divide through by that, right? So it doesn't matter what number b is. It could be a fraction, could be a decimal, could be something weird. It doesn't matter. Divide it by 2, square it. That's what you add to both sides. Okay. Once you simplify whatever's over there, now that you have it in perfect square polynomial form, make it x plus that b over 2 value squared. Take the square root of both sides. Again, I don't care if this looks complicated. I'm up for the challenge. Just take the square root of it, of both sides, and it gives you two equations. Remember, one's the positive version, one's the negative version. That last step is usually just subtracting that part over. Boom. And you got two answers. Again, if you can plug in and get a decimal, that's easier, and there's some things to simplify. All right. Now, as always, let me give you guys one more problem to practice. Boom. Let's try this one. That hard enough for you? So 4x squared plus 20x minus 17. Ready, go. Go ahead and try it. Pause the video. All right, we done? All right, let's do this thing. So hopefully remember first step. Divide it all by 4. Divide this all by 4. Boom. Now, this time, I'm actually going to switch it up. I'm going to do it as a decimal. Some of you are like, what? I did it all as a fraction because you did it the first time. It's okay. Well, I'll check. You'll see if the answer is right at the end. But I'll go through it quickly so you can get right to checking that answer. Because if you divide this is nice. This is just 5. And this part over here, if I do 17 divided by 4, that gives me 4.25. Again, you could leave it as 17/4, I respect that. All right, but now, I notice my b is 5. That's kind of nice. It's just a number. b over 2, because it's odd, it becomes 2.5 if I leave it as a decimal. b over 2 squared, if you square 2.5, 2.5 times 2.5 is 6.25. All right, so what I want is I want a plus 6.25 on both sides. Again, first I'm going to rearrange this. Plus 4.25. So I've got x squared plus 5x, imagine plus blank, equals 4.25 plus blank. What do I want to add on both sides? The 6.25, right? Because now this is a perfect square, which is nice. Because of my formula, I've got, this turns into x plus my b over 2 value. It becomes just x plus 2.5 squared equals, okay, now if I do the 4.25, again, first of all, 4 plus 6 is 10, 0.25 plus 0.25 is another 0.5, so I've got 10.5 over here, right? Should be easy, doesn't even need the calculator, right? This one's maybe a little easier than the one I did together, okay? Then we square root, boom, both sides. When you square root both sides, it's important. We've got x plus 2.5 equals the positive version of root 10.5, or x plus 2.5 equals the negative version of root 10.5, okay? Now, it's time to maybe go ahead and calculate that number if we want a decimal answer. And it's 3.24. So either positive 3.24 or x plus 2.5 equals negative 3.24 minus your 2.5. And what do we got? Our two solutions then are 0.74 or negative 5.74. Boom. So those are our decimal answers. Now real quickly, let me show what it would be in exact form. So the fraction 2.5 is really 5 halves. So you'd have, when you subtract that over, negative 5 halves plus or minus the square root. Again, 10.5 is really 21 over 2. So it'd be this, basically. Alright, so Hopefully we now feel confident in our objective, that after you watch this video, now you can solve a quadratic equation of any form with the completing the square method. Be confident that you can do that math.